Okay, so hello, namaste, and welcome everyone. Welcome to this problem solving session. Yeah, just give me a second. Setting up my things. So this is going to be the 12th session, right? All right. So yeah, so let's get started. Today we will be discussing problems related to week 12 mostly, right? So this is going to be week 12, right? And what was there in week 12? Well, week 12 was mostly based on applications of what we saw in week 11, right? So maybe I will just open week 11 as well. So week 11 was all about hypothesis testing. We saw what is a null hypothesis and what is an alternative hypothesis, and we saw different types of errors, and then saw different problems related to those concepts. So week 12 was mostly about simple tests to basically see if null hypothesis should be accepted or rejected, right? So it basically contained some topics like testing testing of normal means, right? Then so these are very specific tests, testing of uh, normal variances, right? Then there were some large sample tests. Then there were some t-tests, right? So all these were like different kinds of tests to, just uh, basically see if, uh, you know, so these were like tests that will tell you if you should accept the null hypothesis, or should you reject the null hypothesis, right? Um, and like, yeah, I mean, based on all these tests, there were some examples that were solved in the lectures. And so today we will be focusing more on problems rather than explaining these things, because most of these things were pretty straightforward. And I think uh, like it would be better if we just walk the talk, in the sense that we will keep solving problems, and uh, so, I mean, we will keep solving some problems, and as the concepts come, we will keep explaining those. That's, I think, a better approach, given that this is the last week, and I think we will have another problem solving session uh, next week, maybe, or sometime next week. To uh, so that will be like a problem solving session for this entire course. I mean, we'll randomly solve some problems. That's all. Right. So let's get started with some problems, and let's see. So I will assume that you have already seen the lectures, right? And uh, and I won't be explaining things to you. I will just go on and solve the problems, and I will. focus more on solving the problem than explaining the concepts. Okay, so let's get started. Here's the first problem. So the first problem is as follows. So there is a manufacturer of a certain brand of auto batteries. Uh, he claims that the mean life of these batteries is 45 months. So manufacturer claims mean life of batteries is equal to 45 months, right? This is the claim of a manufacturer. Okay. So, and there is a consumer protection agency that wants to check this claim, right? So what they do is they take a random sample. So there is an agency, protection agency, right, which wants to, check the claim of the manufacturer. So what they do is they take 20 random samples or 20 random batteries, right? They take 20 random samples and they find that the mean life of the sample to be 43.05 months. They see they find this thing, right? So mean life they find it to be 43.05 months. And they also see that the lives of all such batteries have a normal distribution, right? So they say they also see that all these batteries have a life which is distributed normally, right, with some unknown mu, okay, and a variance of 6.5 square. The question that is asked is find the test statistic statistic and critical point at 5% level of significance. Okay, so this is the question. So what is said is there is a manufacturer which who claims that the mean life of his batteries are 45 months. There is some protection agency which wants to verify this claim. Okay, whether this manufacturer is telling the truth or is he lying. So what they do is they take 20 random samples of batteries and they check what is the mean life of these batteries and they find it to be 43.05 months. Okay, and they also find that the all these batteries follow the total life of these batteries follow a normal distribution with some unknown mean mu and a standard deviation of 6.5. The question that is asked is what is the test statistics and what is the critical point at 5% level of significance. So what is the test statistics? Test statistic is basically a quantity which will tell you whether you should accept or reject the null hypothesis. So for that, we need to first decide what is the uh, null hypothesis and what is the uh, alternate hypothesis, right? So it's quite simple to decide what is the null hypothesis, right? I mean, whatever the claim of the manufacturer is, you will take that as the null hypothesis or the default hypothesis, and whatever the agency is worried about is the alternate hypothesis. So in this case, H naught, your null hypothesis will be what? It will be that this mu is equal to 45, right? Which is your like default assumption, okay? And your alternate hypothesis, what will that be? That will be simply mu is less than 45. So this is the claim of the manufacturer that you are taking as null hypothesis, and you want to basically, get enough evidence to say that the manufacturer is lying. And if the manufacturer is lying, then this is what you would like to have as the alternate hypothesis. Okay, so just have a look at this thing. So you have a normal distribution whose variance is known, right? Then in these cases, if you have seen the lectures, what will be the test statistic? Test statistic. So, so since the population variance is known, whenever the population variance is known, which is 6.5 square, the test statistic is Z, which is equal to just the normalized version of your x bar, right? So it's x bar minus 45 upon 6.5 over root n, right? This is your test statistic when the population variance is known. If you don't know how this comes, you should go back and see the lectures, okay? So if this is the case, then what will this value be? So we know that x bar is given to you, right? Because x bar they found out to be 43.05, right? So this will be what? 43.05 minus 45, right? Divided by 6.5 into root n. What is n? N is 20, right? So it's root of 20 that will be multiplied. Okay. So if you solve this thing, this comes out to be something around 1 minus 1.34. So use your calculators and you will find this comes out to be minus 1.3416. Okay. This is your test statistic. So this is the like answer to the first thing that they have asked. That is what is the test statistic? Okay. Simple. Whenever you have, so you need to know what is the test statistic when the population variance is known, when population variance is unknown, where the mean is known but the variance is unknown, and all those kind of things. We will solve problems for all of those cases, and we'll see. What is the test statistic for different cases, right? Okay. So so if this is the case, and it is given to us that level of significance is given, right? Level of significance, which is denoted by alpha, is given to you to be 5%, which is 0.05, right? So for when your variance is known, the critical point doesn't depend on the test statistic. Okay, so the critical point just depends on alpha. So in that case, the critical point is just equal to minus z alpha, right? I mean, where z is your standard normal variable, and this will become minus z 0.05, right? Which is equal to minus, I mean, if you use your table, it comes out to be minus 1.65. Where what is Z alpha? This denotes upper alpha percent uh, point of normal 0, 1, right? So this is a simple problem. I mean, you should know that when the population variance is known to you, the test statistic is just the normalized version of your x bar. So you take x bar, subtract the mean divided by your empirical standard deviation, and whatever comes out, this is your test statistic. And the critical point doesn't depend on the test statistic or the number of points here. It is just you take the upper alpha percent point of normal 0, 1, and since z was negative here, you take minus z alpha, which will become minus z 0.05, and use your table, Gaussian table. This comes out to be minus 1.65. So a simple problem, right? Nothing fancy here. Just use uh, whatever you you just need to remember basically which test to use when under a given condition. That's all. If you remember those tests, your work is done. So let's look at another problem. There's a second problem, right? Okay. So the second problem is as follows. A business school claims that students who complete a 3 month typing course can type. Okay, so here is the claim. The claim is that uh, the mean uh, the mean typing speed is at least 1200 1200 words per hour. Okay, so there is a business school which claims that if you take a 3 month typing course from them, the average typing speed of the students is at least 1200 words per hour. Okay, so someone what they do is they took random. So what they so to test this claim, someone takes random 25 students. Okay, who have completed this course, and they find that the population mean, they find this to be what 1150 words per hour. Okay, so someone wanted to verify this claim if the mean average typing speed is 1200 per hour or not. What they do is they take randomly choose 25 students and they see that their average typing speed is 1150 words per hour. Okay, and what else do they see? They also see that population standard deviation, right? Population standard deviation is equal to what? That is equal to 80 words. They also see this thing. Uh, uh, so it is given to you that we can assume that the typing speed for all students who this complete this course have a normal distribution. Okay, so I mean, so it's a normal distribution. However, the mean and variance is not given to us. Okay, so the mean and variance is unknown. And suppose we want to test this claim of the business school. Okay, so uh, if these are the things, you are given some statements and you have to tell which of the statements are true. Maybe I will repeat the question again. Okay, so there is a claim by a business school that whoever takes the 3 month course of their program, the typing speed of the average typing speed of a student becomes at least 1200 words per hour. Okay, so to test this claim, what they do is they take randomly choose 25 students and they get the statistic that the average typing speed is 1150 words per hour and with a standard deviation of 80 words. It is given to you that you can assume that the actual, typing speed of students is distributed according to a normal distribution. However, the mean and sigma square are unknown to you. The question that is, so there are multiple statements that are given to you, and you have to tell which of the statements are true and which are not true. Okay, the first statement is the value of this statistic is 3.125. So you need to recall what is the test statistic when mean and variance both are unknown. Okay. Second statement is critical point at 5% level of significance. I will use LOS to denote level of significance is 1.71. This is the second statement. Third statement is based on the sample, based on the sample, we reject the claim. So based on these statistics and the critical point, should we reject we should reject the We should reject the what? The claim of the business school, right? This claim. Okay. And D option is the test statistic follows normal distribution. This is the fourth thing, right? Okay. So these are the statements. We have to verify which of these are correct, right? So let's see. It's a simple thing again. Just need to remember the basics. Okay. So we have to assume that typing speed is distributed according to a normal distribution with some unknown mean mu and unknown sigma square. Okay, that we will have to assume, and it is given to you that you can assume this thing, right? So if that is the case, what is your null hypothesis? H naught is basically that the mean mu is greater than or equal to 1200, right? That is what the claim of the business school was. And what is the alternate hypothesis? Well, the alternate hypothesis, since you have seen that the population mean is less than 1200, so your alternate hypothesis will be that mu is less than uh, 1200. This will be your alternate hypothesis. Now, in this case, uh, uh, this sigma square is unknown to you, right? I mean, in the previous case, if you remember, where was it? Yeah, if you remember in the previous problem, it was given to you what is the actual, okay, I think I wrote it incorrectly. Just a second. This should not be population, right? This should be sample. Sorry. So, whatever you see from sample is called sample mean and sample standard deviation. And these means and these sigma square, these are population means and population variance, right? In the previous problem, it was given to you that the population variance is 6.5 square. Okay, it was known to you. Hence, the test statistic that we used was this one. Okay. However, in this case, the population variance is unknown. When your population variance is unknown, what is the test statistic? When your population variance is unknown, the test statistic is denoted by T is what? It is actually this thing. You have your X bar again, right? Minus 1200 upon uh, S S by root n. Okay. Here, remember, here we used the standard deviation, right? Population standard deviation, which was 6.5, which was given to you. Okay. However, here we don't know the population variance, right? We don't know what is sigma here. However, we know the sample standard deviation. Okay. So instead of population standard deviation, we will use the sample standard deviation here instead. Okay. This is your test statistic. Okay. And what will this come out to be? So X bar is known to you, 1150, that is given to you, minus 1200, okay, divided by what is S? S is given to you to be 80, right? Divided by root n. Root of n is given to you to be how much? 25, right? So root of 25 is 5. This thing. So what will this thing become? This will become minus 50 divided by 16, right? What is this thing? It's two eights are 225. This will become minus 8 threes are 24. 1 0 8 ones are 8. 2 0 8 twos are 16. 4 0 8. Minus 3.125, right? So this is your test statistic. So a simple so it was almost like previous problem. However, you should be careful. Last time the population variance was known to you, so you directly use 6.5 here. This time population variance is unknown, sigma square is unknown. So what you do is you use the sample variance and replace it here in the test stat to calculate the test statistic. Okay, so t comes out to be this thing. Now what is the so okay? However, uh, when your variance is unknown, right? Both population mean and population variance is unknown. Then you should remember that t here xz followed your standard normal distribution, right? And that is why you were simply able to calculate the critical point without taking into account the number of samples or anything, right? Because standard normal is, independent of these things, and you can directly calculate the upper percentile, and it's easy. However, here, since variance is unknown, t will actually follow what? It will follow a t distribution, okay? It will follow a t distribution with how many degree of freedom? With n degrees of freedom, where n is actually your number of samples, okay? So it has 25 samples. So the test statistic will follow a t distribution with 25 degree of freedom, okay? For this reason, what will be the critical point now? Critical point. So now the critical point won't be calculated using standard normal distribution. It will be calculated using your t distribution. Okay. What will that thing become? Since this is negative, it will be minus t. So it's so critical point for a t distribution is t alpha comma n, right? What will this thing become? So it's n minus 1, yeah? Right. So this thing will become minus t 0.05 comma 24. And if you have the table of your t distribution, this thing comes out to be minus 1.71. Okay. What is t alpha comma n here? Again, it's simply your upper alpha percent upper alpha percent point of t distribution, right? With n degree of freedoms. This will be n minus 1. So 25 minus 1, 22. Right? So this is your critical point, right? So you have calculated the test statistic, you have calculated your critical point. Now, given this thing, will you accept or will you reject the uh, the null hypothesis is the question, right? So do you accept the null hypothesis or do you reject the null hypothesis? So for t distribution, since you are dealing with t distribution, since your test statistic t is it is less than the critical point, right? It is less than the critical point, right? Minus 3.125 is less than minus 1.71, right? This thing implies that we reject H naught, right? We need to reject H naught at level of significance 0.05. This is what will be our final. So based on these samples that we have seen here, and the test statistic and the critical point, we observe that the critical point is greater than the test statistic. So we don't have so we have enough evidence to reject the null hypothesis. So we will reject the null hypothesis in this case. So coming to these options, which of the options are true? The value of test statistic is minus 3.125. It's not plus 3.125. So this is incorrect. Critical point at 5% level is 1.71. No, it's minus 1.7. So remember, you need to remember the sign all as well, right? Based on the sample, we reject the claim. That is correct, right? We have rejected the claim. And the last thing is test statistic follows normal distribution. That is incorrect because the population variance is unknown. So it follows a T distribution, and hence this thing is also incorrect. So the only option that is correct is the C option. Okay. So, all right. Uh, so this was your second question. Let's see some other question, right? Uh, right. So, what is the next question? The third question that we'll see. Okay. So this will be comparison of means question. Okay. Let us see what it is. Okay. I'll solve this question first. Okay. So a sample of 50. So there are two samples that are given to you. Okay. So there is a first set of samples. What that sample? So there are N1. You have the number of samples is given to you to be 15. Okay. So this is actually a problem statement. However, I am simplifying it to write in terms of just maths. Okay. So yeah, so the first set of samples contains 15. Maybe I'll read the question first, right? And then maybe I'll write it down. So a sample of 15 children from New York State showed that the mean time they spend watching television is 28.2 hours per week. Okay. So N1 is 15, right? And uh, let's say X bar, right? The sample variance, the sample mean that is given to you to be 28.20, and uh, your your standard deviation is also given to you. S1 is given to you 4 hours. Okay, maybe I'll just write 4.0. So so first you sample 15 children from the state of New York. You observe that the all the children, the sample, the average time that these children spend watching TV is 28.2 hours with a standard deviation of 4 hours. Okay. Then what you do is you take another sample of 10 children, so N2 is equal to 10, from California. This time you take the children from California. The first sample was taken from New York. This time you take it from California, right? And this time you see that the mean time that they spend watching television is 24.50 hours, okay, per week, with a standard deviation S2 equal to 5 hours, 5.0. Okay. Now suppose we want to test whether the mean time spent watching televisions by New York State is greater than that for children in California. So you want to basically test if the children from New York, if this is the New York data, this is a New York data, and this is your California data. You want to basically conclude if the children in New York spend more time in front of television compared to California. Okay, this is what you want to check, right? So the question asks you find the value of test statistic and the critical point at 5% level of significance. Assume that the two populations are normally distributed and that the standard deviation of the two populations are equal. So let us denote this like the random time spent by children in New York to be X. That is given to you to be normally distributed according to some mean mu1 that is unknown and some sigma square. Okay. And from the random time spent by children in California, that is distributed according to another normal distribution. However, with some different mean mu2. However, the variance is same. That is sigma square. So it's like there are two distributions. Okay, this one and this one. Okay, you have samples from this distribution, which and so you have samples from this distribution, and like you have 15 samples. The average sample mean is 28.2. The standard deviation is 4.0. Then you have samples from this distribution as well. 10 samples to be specific. The mean sample mean is this much, and the standard deviation is this much. The question that is asked to you, so these are, so okay, this data that is that I'm highlighting, this data is empirical data that you have observed from data, okay, from samples that you have observed. However, you want to comment on the actual mean, mu1 and mu2. So the question that is asked is whether mu1 is greater than or equal to mu2 or not. So how do you solve this? It's simple. You first define your null hypothesis, okay. What is your null hypothesis? The null hypothesis is what you are observing. It seems that x bar is greater than y bar. So it seems that, mu1 is greater than or equal to mu2. Okay. And h1, which is your alternate hypothesis, is the opposite. Mu1 is less than mu2. Okay. Now, now here you need to know what you need to know is the standard deviation of two normally distributed population are equal, uh, right? So the standard deviation here is equal but unknown. So sigma square and sigma square, both the distributions have same standard deviation. So in this case, when you have to compare the means of two Gaussian distribution whose variance are unknown but they are the same, what is the test statistic? I mean, these are just things to remember. So test statistic in this case will be again T. What will this thing be? This thing will be simply root over n1 n2 over n1 plus n2 times x bar minus y bar upon sp, where x bar and y bar are your sample mean that is given to you, right? However, what is sp? sp is your what do you call it? It's the pooled sample variance, right? And what is it equal to? So the pooled sample variance sp square is equal to what? N1 minus 1 times S1 square plus N2 minus 1 times S2 square divided by N1 plus N2 minus 2. So it's like, so since N1 and N2 are not equal, right? Uh, if these are not equal, then you cannot take the sample variance as it is, right? You need to adjust the sample variance, and the way to adjust the sample variance is like this. Okay. So N1, N2, all of these variables are known to you, right? So this will become what? 15 minus 1 times S1 square. S1 square. So S1 is known to you, which is 4. So S1 square is 16 plus N2 minus 1. N2 is given to you to be 10 minus 1 times S2 square. S2 is 5. So S2 square is 25 upon N1 plus N2 minus 2. So 10 plus 25, 15, which is 25. 25 minus 2 is what? 23, right? So, so what will this thing become? This thing should become what? Uh, should I calculate this? So, I mean, it will come out to be something. I mean, I don't want to calculate this. You can use your calculator to calculate this, okay? However, what SP, whatever this value is, you take the square root of it, you get SP. Okay. Now, what will be the test statistic then? T will be root over n1 n2 over n1 plus n2, right? Root over 10 into 15 over 10 plus 15, right? Into x bar minus y bar. X bar, what was it? X bar was 28.220 minus y bar, what was y bar? 24.5 divided by SP. SP is this thing. So SP is 14, 16 times 14, sorry, plus 25 times 9 divided by 23, right? So this will be your test statistic. You use your calculator. Since I already have the answer in front of me, I will just write it down. This thing comes out to be 2.051. Okay. And since the level of significance was given to you to be alpha to be equal to what? 5%, which is 0.05. Again, for this test statistic, T is distributed according to the T distribution. However, the degree of freedom here is n1 plus n2 minus 2. So what will be the critical point? Critical point, since your this thing is minus T, what will it be? Alpha, your level of significance, alpha comma degree of freedom. What will be the degree of freedom for this test statistic? Simply n1 plus n2 minus 2. Okay, so this becomes minus t 0.05 comma n1 plus n2 minus 2 is 10 plus 15 minus 2, which is 23. And you use your table, this comes out to minus 1.71. Okay, where this thing is again like the previous question, it is alpha percent point of t distribution, right? So these were the things that were asked to you. The critical point, which is 2.051. So sorry, the test statistic, which is 2.051, and critical point, which is minus 1.71. So in this case, you have t is greater than the critical point, right? Since t is greater than the critical point, unlike the last case, yeah, here t was less than the critical point. Here t is greater than the critical point, so you can accept h naught, right? Simple. Okay, so I mean, this was another question where you had to compare the means of two distribution. So these are like different flavors of like same thing, right? In the first question, the variance was known and it was a simple question. You just used the test statistic was also simple. In the second question, there was just one difference that you didn't know the population standard, population variance was unknown to you. In the third problem, the question was altogether different, right? That you had two populations and you had to compare the means of these two populations. But essentially, you had to again compute the test statistic, compute the critical point, and like check if the critical point is greater than or less than the test statistic, and then accept or reject the null hypothesis. Simple, right? Okay. So this was the third question. Uh, okay. So let us look at another question, right? This one is again like again you have to compare the mean of two populations. Okay. However, here the question is uh, goes one step further. Okay. Here you had population variance were same. What if the population variance is also different? Okay, this will be the next twist that will come. So in hypothesis testing, like this tests, it's all you need to do is you need to remember the different variants. That's all. If you remember the different variants, you can easily solve the problems, and you just need to remember the formulas. So what is the fourth question? Just a second. Okay. So the fourth question is as follows. Uh, okay. So there are two brands, okay, brand A and brand B. Okay. The brand A provides a medicine, and the claim of the company is that brand A gives faster relief than as compared to brand B. Okay. So there are two medicines, A and B. The someone claims that the brand A medicine gives faster relief compared to brand B uh, medicine. Okay, and then what someone does is they collect like they collect samples from both the brands. Okay, and basically they have to check if this claim is true or not. What is the claim? The claim is A provides faster relief. So you can see these are all like practical problems as well, right? I mean, someone can claim anything, but how do you decide that if the claim is reliable or not? So these tests are for that purpose only. Okay, so let's say this is brand A, brand B, and someone goes and collects sample from both the brands. Okay, the release time for each of the brands, and they get these the following samples, right? First is 47.7, second is 52.8. So these are all in minutes, okay? So these are minutes to get relief from the pain. Third third one is 51.9, 44.1, 55.8, 51.5, 52.1, 40.8, 53.1. Maybe I will continue here. 53.1, 46.1, 47.9, 45.7, 46. Okay. So these are the relief time that one observes for brand A. For brand B, they observe 50.0, 57.4, 52.7, 58.6, 54.0, 56.3, 52.5, 50.8, 49, and 58.2. That's it. So there are less samples for brand B and more samples for brand A. Okay. So let's denote the random variable for this thing brand A to be X and for brand B to be Y. Okay. So it is given to you that X follows a normal distribution with some mu1 comma sigma 1 square. Y follows a normal distribution with some different mean, but this time the variance is also different, sigma 2. In the last question, the sigmas were same for both the distribution. Suppose we want to test whether the company's claim based on the observed data samples is true or false. Okay. Then there are some statements that are given to you. What are the statements? The first statement is the distribution of the test statistic, whatever, let's call it T, right? Test statistic T has approximately T distribution with 20 degree of freedom. That is the first statement. Second statement is the value of test statistic is minus 3.102. Third statement is critical point alpha is 0.05. The 5% level of significance is equal to 1.72. And the fourth statement is we reject the claim of the company. So these are the four statements we have to tell which is true, which is false, and so on, right? So again, it's simple. What will be the null hypothesis? The null hypothesis is what the company is claiming. That is mu1 is less than or equal to mu2. Okay. I mean, if that is the brand A provides faster relief compared to brand B. So if that is the case, then mu1 should be less than or equal to mu2. What is H2? So H1? H1 is the opposite, right? Mu1 is greater than mu2. So in this case, when mu1, mu2 are different, sigma 1, sigma 2 are different, what is the test statistic? In this case, the test statistic is again first. I mean, I should write down the expression, right? So the test statistic when mean and variance of the population are different, it is simply x bar minus y bar upon root over s1 square by n1 plus s2 square by n2. So x bar and y bar are sample means and s1 square and s2 square are sample variances, right? So using this data, if you calculate these x bar, y bar, and all these things, so x bar comes out to be what? This comes out to be 48.88, and S1 comes out to be 4.32. Okay, for the second brand, Y bar comes out to be 4 point, sorry, uh, comes out to be 53.95, and S2 comes out to be the sample standard deviation comes out to be 3.50. Okay, these are what you get. So in this case, and if you substitute all these things here, what will this thing become? This thing will become x bar minus y bar, right? 48.88. Yeah, 48.88 minus 53.95 divided by S1 square, 4.32 square by N1. What is N1? N1 is 13 that you can count. S2 square, that is 3.50 square, divided by N2. N2 is 10, right? So this is what your test statistic will be, right? And if you calculate this, this comes out to be minus 3.102. This is what you get. And in this case, where the mean and the variance both are unknown, the t statistic actually, the test statistic follows a t distribution again with a degree of freedom nu. Okay, what is nu? Nu is in this case comes out to be this is the ceiling function, okay, or maybe I should use the floor function. So the floor function is s1 square by n1 plus s2 square by n2 whole square divided by S1 raised to 4 upon n1 square into n1 minus 1 plus S2 raised to 4 upon n2 square into n2 minus 1. This is the floor function, okay? So floor function is the largest integer that is less than or equal to this thing. So all of these variables are known to you, right? And if you calculate this, then mu comes out to be floor function of 20.9069. This thing, if you use the floor function of this thing, then what is the largest integer that is less than or equal to 20.9? That is simply 20. Okay. So if that is the case, so nu comes out to be 20. So T is actually distributed according to T distribution with 20 degree of freedom. Okay. So the 20 degree of freedom is 20 in this case. Okay. Now, what will be the critical point? Simply, critical point is always what it is simply T alpha comma nu, right? Alpha is your level of significance, T 0.05, and nu is what? Nu is your degree of freedom, which is 20. This, you use your table, this comes out to be 1.72. So, so since critical point is positive in this case, right? Uh, and what was the value of T, your test statistic, that was minus 3.02. So in this case, T is less than your critical point, right? T alpha comma nu. However, you need to remember that this time the critical point is positive. So if the critical point is positive and the test statistic is less than your critical point, then this implies that we do not reject H naught. So we don't reject H naught. Okay, so we accept H naught. So what was H naught? H naught was the original claim. So in this case, we will accept the claim of the company. So, so which of the statements are then true and which of these are false? So T follows this T distribution. This is correct. We just saw. The test statistic is minus 3.102. That is also correct. The critical point is 1.72. That is also correct. However, the last statement is wrong. We reject the claim because the test critical point is greater than 0. We can, and in that, if the critical point is greater than 0 and the test statistic is less than the critical point, then we don't reject the null hypothesis, right? So this was your fourth question. Again, I mean, nothing fancy. You just need to remember the conditions. Okay, when to accept, when to reject, what is the test statistic in a particular situation, all those things. That's all. If you remember that much, then you're done, right? So let's look at another problem, maybe. Let's solve two or three more problems and then we will stop, okay? Because I don't have more problems, it seems. Hmm. So here is the fifth problem. So a company sent 7 of its employees to attend a course in building self-confidence, okay? These employees are evaluated for their self-confidence before and after attending this course. The following table gives the score of these employees before and after they attended the course. Okay, so there are employees of a company. They were sent to some course, and so you are given the scores of these employees before the before the course and after the course. So what is that data? Before and after, right? These are the things that are these are the two things that is given to you. So before, the scores of these employees were as follows: 8, 10, 5, 8, 4, 5, 9, 11, 6, 6, 9, 7, 5, 9. So these are the scores, okay? And you want to test whether the attending this course increases the mean score of the employees, okay? So you want to basically see if this course has helped the employees or not. So so it is given to you that assume that we can assume that uh, population population of paired differences has a normal distribution, right? So this is given to you. So then the question is, what is the value of test statistic and what is the critical point, right? So this is again simple. So let's say that X is the score before, right? And Y is the score after course. Okay. It is given to you that the population of pair differences has a normal distribution, right? So it's like, so what is given to you, X comma Y follows a normal distribution, okay? Uh, if that is the case, then the difference, right? The paired difference, this thing is what defined as expected value of X minus expected value of Y. Let mu D be this thing, right? It is the difference between average scores before and after the course, okay? What will be your null hypothesis? Null hypothesis will be that mu D is less than or equal to 0. That means that, if after the course, if the mean has increased, then this thing will be actually negative. That is your null hypothesis, which is the claim of the course, okay? And H1 will be what? Mu D is greater than 0, right? So if you look at the data, so what will be the differences? You need to first calculate the differences here, right? So what will be the difference here? 8 minus, uh, wait, yeah. So if you calculate the differences here, it will be 10 minus 8, right? 10 minus 8 is 2. 8 minus 5 is 3. 5 minus 4 is 1. 11 minus 9 is 2. Right? 6 minus 6 is 0. 7 minus 9 is minus 2. 9 minus 5 is 4. So this is the data of differences that is given to you. Right? So maybe I will write it down here. So what is the data? So D1 is 2, D2 is 3, D3 is 1, D4 is 2, D5 is 0, D6 is minus 2, and D7 is 4. So this is the data that is given to you, right? Then what is the value of test statistic? So in this case, when you are looking at pair differences, test statistic is simply what? You just calculate D bar, right? D bar by SD by root n. This is your test statistic, right? Where SD is your sample standard deviation. So this thing, if you calculate the average, this thing comes. So root n is root 7 times d bar, that is 1.42857, divided by standard deviation. Again, you can calculate the standard deviation, that comes out to be 1.98806. These things can be calculated using a calculator. This thing comes out to be 1.901, right? So d bar, and maybe I'll just write it down. 1 by d bar is just 1 by 7 summation di. Okay. and SD square is nothing but 1 over 7 minus 1 summation uh, di minus d bar whole square. So it's like the population variance and population, sorry, sample variance and sample mean. That's all. What will be the critical point? Now, critical point again, this thing will be again just using since this is a pair difference, again critical point will be decided using the t distribution, which will be t alpha comma n minus 1, right? Which is t 0.05 comma n is 7, so 7 minus 1 is 6. This comes out to be 1.94, right? So the question was, what will be the test statistic? Test statistic you have computed that comes out to be 1.901, and the critical point comes out to be 1.94. So since the critical point is greater than 0 and test statistic is less than this thing, so you have to accept the null hypothesis, which is that the null hypothesis was that mu d is less than equal to 0. That means that the test actually, the course has actually worked and the confidence of the employees has actually increased, right? So yeah, I mean, this was like another question where the, again you have to kind of remember what is the test statistic, right? Now I will take one last question, right, which will be based on the variance of the normal distribution. Till now, we have just seen problems on means of the normal distribution. This will be last question that we'll see will depend on the variance of the standard normal, not standard, but just a normal distribution, Gaussian distribution. The question is as follows: the burning time of a chemical of two different formulations is given in the following table. Assume that these follow normal distribution. Okay. For test the hypothesis that the two variants are equal, what is the value of the test statistic? So, so there are two chemicals and the burning time of these chemicals are given to you. Okay. So type 1, type 2. There are these two chemicals, right? And the burning time of these chemicals is given to you, right, in minutes: 71, 65, 84, 73, 65, 80, 67, 58, 82, 76, 85, 79, 66, 61, 58, 61, 77, 70, and there is one more, 70, 82. Okay, these are given to you. Okay, so let's call this random variable x and this random variable y. So it is given to you that x follows normal some mu1 comma sigma 1 square, and y follows some normal mu2 comma sigma 2 square. Okay, this is given to you. The so the null hypothesis. So the question is if the two variances are equal or not. So you can say create your null hypothesis, which is sigma 1 square is equal to sigma 2 square. Okay, this is what you want to accept or reject. And the alternate hypothesis is what? Sigma 1 square is not equal to sigma 2 square. So i- when you are comparing the variances and the means are also different, and this thing is, so if the means are different and you want to compare the variances, what will be the test statistic? In this case, the test statistic is no more your t distribution. Okay. In this case, your test statistic is actually f, which is s1 square by s2 square. Right, where S1 square and S2 square, these are sample variances, right? So using the data that is given to you in the table, you can calculate that S1 square is actually equal to 82.944, and S2 square is given comes out to be 77.611. Okay, and hence the value of test statistic F is 82.944 divided by 77.611. This comes out to be 1.0687. Okay, right. So yeah. So yeah, this was the last problem that I had. This was this was different in the sense that you had to calculate the this was regarding comparison of variances. Okay. So till now we were solving problems where we had to compare the mean. However, in this question, we had to compare the variances. And whenever you have to compare the variances, you need to look at the F distribution. That is the main point, right? So, and the test statistic is just the ratio of the sample variances. That's all. So, yeah, that's all for from my side that I had today. Unless you had any more questions. If you have more question, then we'll solve it. Otherwise, we'll stop. So today's session was, there is nothing in actually these problems because you just need to remember. It's more about remembering stuff than actually logically thinking. So you just need to remember that okay, if these things are given, then what do I need to do? If those things are given, what? It's just that something you need to remember. You can you can actually make a cheat sheet of these things and paste it on some wall. Just look at it whenever you wake up or whatever is convenient time for you, right? That way it will be easier for you to just remember these things. So okay, I mean, if you don't have any question, we will stop. uh, okay, so okay, so I'll stop it from here. Okay, right. So okay, so thanks for joining, and yeah, thanks for joining, and have a nice day. See you in the last session, maybe this week, next time, probably. Okay, thank you.